This section is about graphing linear inequalities. As you can probably guess from the title and the fact that there's a graph on this page, it might be a nice idea for you to have graph paper. It'll make your life a little easier. So our first problem actually is going to have no graphs in it, but everything else after that will have a graph. So let's start straight away with the first example. I'm going to ask you, is 14,9 a solution of any of these three equations? You're going to put yes or no. So my first thing I need to know is that 14 is my x value, 9 is my y value. Remember, they're in alphabetical order. It's always x, comma, y. So let's go ahead and plug them in and see if we can figure out if it's yes or no. So I put in 14 for x, I put in 9 for y. I end up getting 5 is greater than or equal to 8. I know that 5 is not bigger than 8, so that's a no. I'm going to do the same thing for the next ones. Now, B is a little bit tricky because a lot of people say, oh yeah, 5 equals 5. However, we're not looking for 5 equals 5. We're looking for 5 is less than 5, which it's not actually, so that one's going to be a no. On part C, I am going to put in 9 for y, put in 14 for x. I end up getting 18 minus 14 is less than or equal to 4. 4 is less than or equal to 4. So actually, unlike part B, this one is true because it has that or equal to. So that one's my only yes there. So just be careful that you know the difference between those three. For the rest of my examples for the day, they're all actually going to have to do with graphs. So for those ones, we're going to have a few things we need to remember. The first thing is that if we have either less than or equal to or greater than or equal to, we are going to have a solid line. And if we have less than or greater than, it's going to be a dotted or a dashed line. So I know the dashed lines are a little harder to draw than the solid ones. If you want, you can try to draw it solid lightly and then erase the dashes in between, or you can just try to draw it, do the best that you can. The other thing we need to know is that you're also going to be shading in this one. So you are going to shade below if you solve for y and you get either y is less than or y is less than or equal to. And the opposite is going to be if you get y is greater than or y is greater than or equal to, you're going to shade above. Okay, I'm actually going to go on to the next slide, and we will do some examples, lots of them actually, so you can see what I mean by some of these. For our next section, we're going to do a bunch of examples with graphing, and I'm going to ask you to graph the inequality. So the first one I have is y is less than or equal to 3x plus 1. Each of these problems has 3 steps. The first step is that you are going to decide if you are going to have a solid line or a dashed line. And if you look at the previous slide, or if you look up in your notes, you'll see that because we have it less than or equal to, it is going to be solid. The second thing you need to figure out is if you're going to shade above or below. And once again, if you look back in your notes, you'll see that because it's y is less than or equal to, it is going to be below. And the last thing that you need to know is we are going to graph the normal equation y equals 3x plus 1. Now, if you remember graphing, I'm hoping you remember that this one has, if you think about y equals mx plus b, it has a slope of 3. We're going to write it over 1. And it has a y-intercept of 1. Hopefully you remember a little bit about graphing. So we're going to start with our y-intercept. In this case, it's up at 1. From there, we're going to use our slope to tell us where to move. We're going to move up 1, 2, 3, write 1, and then draw our second point. Then, between those 2 points, we're going to draw a solid line. Make it a normal line. Try to make it nice and long. From there, we are going to shade below that line. So we're going to shade below it. You can use another color if you want to. You can use the same color. Make sure that you get all below the line. You don't just get a little bit below. Try to get the entire thing below that line. And that's our first example. So go ahead and take a look at this next one. I want you to start by figuring out a few things. So I want you to figure out if it's solid or dashed. I want you to figure out if you're going to shade above or below. And I also want you to figure out when you graph it, what is your slope? What is your y-intercept? If you think you're good with all those things, give it a try. You can pause and do as much as you can. So this one, you'll see that because its y is greater than, there's no line under it, it's going to be a dashed line. Because it's greater than, we're going to shade above the line. We also know that with our equation, y equals negative 2x plus 4, our slope is negative 2. We're going to write it over 1. Our y-intercept is positive 4. So then you're going to draw your line by starting with your y-intercept. It's up on the y-axis at 4. Then use your slope to move. We're going to move down 1, 2, and over to the right 1. From there, we are going to now draw a dotted line or a dashed line. Draw it the best that you can. You'll notice that mine isn't perfect. That's okay. So then you're going to shade above the line. And in this case, it's a little bit to the right, but it's all above the line. If you want to use highlighter to shade it, that's fine. But when you do that, make sure that you are 100% certain that you're doing it the right way. For our next two examples, you might notice that they look quite a bit harder. So we can start off by already knowing if we're going to have a solid or dashed line. For the first one, we know it's going to be dashed because it's less than. However, you have to do a little bit of work before you know if you're going to shade above or below. You also have to do a little work before you actually graph the equation, graph the inequality. So I'm going to do what I learned I learned it a long time ago. You guys did it in the last chapter, though, or the last few chapters. And I need to use y equals mx plus b, which means I need to solve for the y in this one. I'm going to do that by moving over that x. That gives me 4y is less than negative 8 minus x. And I then am going to divide every single thing by 4. That gives me y is less than negative 2, and I end up getting minus x over 4, but if you want, you can think of this as minus 1x, so it's going to be minus 1 over 4 times x. If you if it makes you feel more comfortable, you can rewrite it so that you have your x value first, which is the negative 1/4. Feel free to do that if you want to. So now we have a little bit more that we can do with the problem. We knew it was dashed. What we didn't know is if we were going to shade above or below, but now that we see that it's y is less than, we know it's going to be below the line. We also know that our inequality has a slope of negative 1/4, and we know that it has a y-intercept of negative 2. Let's go ahead and graph this. So we're going to start with our y-intercept at negative 2. Then we use our slope. It's negative 1/4. That means we go down 1, right 4. Draw another point from there. We also know it's a dashed line, so you're going to draw your dashes. Once again, I hope yours looks a little better than mine. It should if you're using a ruler. We also know that we're shading below this line, so we're going to shade all below that. And we are done with that one. So 5, you can try it on your own if you want to, but this one has a special trick involved that involves the basic things that you learn about solving inequalities. So it's up to you if you want to try it on your own. But for this one, if you want, you can just watch. So for this one, I'm going to start once again by solving for y. And don't worry if you are if you wrote it as 12 plus 6x. I like to put the x first. It's 6x plus 12. The next thing I'm going to do is I have to divide everything by negative 3. However, it's important that you remember that if we multiply or divide both sides by a negative, we have a special rule. So our special rule is that we have to reverse the inequality sign. I'm going to write a note here. So do not forget to reverse the inequality sign when you are multiplying or dividing by a negative. It's really, really important. It's one of those things that it's a tiny, tiny step, but if you forget it, the entire problem is going to be off. So try to remember that, because otherwise your entire problem is wrong, and you don't want that to happen. Now that we have the correct inequality solved for y, we know that it's a solid line because it's less than or equal to. We know that because it's y is less than or equal to, we're going to shade below it. The other thing we know is that our slope is negative 2/1. Our y-intercept is negative 4. So I'm going to go ahead and draw my y-intercept down at negative 4. I go down 2, write 1, draw my line from there. Don't forget it's solid. We're going to shade below the line. And it's going to look like that. The next two are actually our last two problems. These ones, if you know what to do, they're actually easier than all the other ones. If you don't know what to do, then they're definitely going to be a little harder. So for number 6, first thing you can figure out is that it's a dashed line. You can also figure out that we're shading above our line. However, now you need to figure out what the line actually looks like. So you may remember from a few chapters ago, if you had something like y equals 5 or y equals a number, it was a horizontal line. It's actually the same if you have y is less than or y is or greater than any number with no x in it. It's always going to be a horizontal line. And it's going to be a horizontal line at y equals negative 3. So that means I'm going to draw my line down there. And I just made a mistake, which was that I did not make it dashed. Luckily, I can go through and change it. So I'm also going to shade above that line, which is going to be everything up here. The next one's a little harder. So the first thing I want you to notice is that we need to move over that 3 so that the x is by itself. Whenever you see just numbers hanging out, try to put them together if they are like terms. Like if you have 2 constants on different sides, they're like terms. So it's a good idea to put them together so you can simplify the problem a little bit. So when I do that, I get x is less than or equal to 4. I know one thing, and that's that it is a solid line because it's less than or equal to. However, in the previous one, I knew that I shaded above if I was y is greater than, but there's no y in this one, so this one's a little weirder. But one thing I can figure out is if I remember from previous sections that if I had x equals a number, I had a vertical line, and this is the same. So when you do that, you are going to go over to x equals 4 and draw a solid vertical line through it. Now what you have to figure out is where you're going to shade. You have 2 options. You can either shade to the left or you can shade to the right. So I want you to think about which values are less than or equal to 4. Would it be to the left or to the right? And I'm hoping that you said that less than would be stuff to the left. So I'm going to shade everything to the left of that line. And that's all I do for that one.